Okay, I'm recording now. Is my audio okay? Ish.
A little bit fuzzy.
Yeah, it's got that robot stutter thing
Perfect.
happening.
Perfect. Well, I apologize for that. So I will just go ahead and turn it over to Mark, and he can get going, and hopefully has better audio.
Okay, let me share my screen. Oh, shoot. Grant access. Oh, man. Should set this up. Zoom. Okay.
Having trouble sharing?
Yeah. Let's see here. Oh, well, here we go. Let me pull up the PowerPoint. Share. Okay, so you should all see a PowerPoint deck slide. All right, great. Okay, so this presentation shouldn't take too long. Our title is called Towards More Unit Testing. So why do we care about it? Reason why is that currently the state of our tests in Volttron, they're mostly integration tests, and they take a lot of setup, and it's almost as if it's its own code base in a sense, because the amount of setup compared to the code being tested is quite a lot. And it's also very hard just to get it up, just to write it up and to get it to run, because it takes a while. And on top of that, getting it to work in Travis has also been a pain point. So instead of trying to test the whole suite, we'll test instead write unit tests or write unit-ish tests. That'll make it easier for developers to both run the tests and also to run their own tests and make it work in whatever CI tool they're using. And so the component that we're focusing on today is testing the historians and database utils functions. One thing to note about historians is that the historians, our first point here is that they depend on these DB utils objects that access the database. So if you think about it, these historians don't talk to the database directly, they just wrap around these DB utils objects that then give us access to it. And currently the way we test our historians is that we run these end-to-end integration tests. But as I mentioned earlier, it takes a lot of time. Sometimes it won't even run on your IDEs or on Travis. And so what we did instead is, instead of testing the historian directly, test the workhorse, the actual thing that does the real work for the historian, which in this case, to talk to the database. And so to focus on testing the DB utils. When I first started writing out these tests, these unit tests for them, I realized that I was mocking, or I had to mock the database, whatever we had. So if it was a SQL database or Mongo, whatever, those had to be mocked. But then if you think about it, the unit tests then are kind of silly because there's no value in it. They're not really testing the connection and the behavior, you're just mocking it. So instead what we did is we created these things called level 1 integration tests, where we just take a standalone, we create a real database, but using a Docker container to act as our production database, and then we make calls to the database to ensure that our CRUD operations are actually working as expected. Some of the goals for this was to really test the connection and the behavior of these DB utils classes, which are the workhorse for historians. We also want to test the ability to run over different versions of whatever database we're running, such as MySQL 8 or 5.7 or 5.6. We want the ability to run it locally and then test it, then run our Docker script locally, and then also to run it on whatever CI tool we're using, such as Travis. So one way to think about these tests is there's really three main things that we're focusing on, specifically the DB utils class. We have to create a container to act as our production database, and then create our own test dedicated connection to the container so that we can verify the behavior. One way to think about these tests is the way I set them up is we arrange our data or our tests. So create the container and seed it, call the method that you're testing, and then make any assertions verify the behavior. When you think about these tests in general, what we're doing within the container itself is for the test container that we're creating, with each test, it's creating its own separate dedicated database container, running whatever test it's doing, and then cleaning up. And then go to the next test, do the same thing. And so for every test, you're getting a fresh instance of whatever database you're using. So between tests, they're not sharing the same database. We're actually being even more strict and saying, all right, we know exactly the state of this database, and we have confidence that whatever we're verifying is actually the behavior. So I'm going to switch gears now and then switch to the code and do a little demo here. So let me share screen, switch to PyCharm, share, and you should all see, is the font good? Can people see that?
That looks good to me.
Okay, yeah, I made sure that ahead of time this was big enough because that's always been a pain point in these presentations. So what we have here, let me close this out. What we have here is the level 1 integration test for the Postgres Funcs class, which is the workhorse for the SQL historian or Postgres SQL historian. And point a couple things out here. I'll skip over a lot of details, but the one thing we have here is this list of images that we're testing. And right now I'm only testing one image just for time's sake. And in this case, if you want to test other images, you can add, Postgres, 8, or you'd have to type it all out, whatever, but you would add Postgres 8 here if you want to test out that image as well. But right now, I'm only testing out one just for sake of time. And then let's focus here on one specific test. And this is basically the same pattern for every test. What we're doing is we're getting the container, setting it up, and then we have to wait for it to cook. So grab a connection. And then from there, we then set up our tables or our database however we want, and then run our assertions. So in this case, we're testing the method set up storing tables, and that's this method right here. And so it's quite simple. Just call the method, and then using our test connection to the database, we assert or we grab the tables, and then we assert what we expect those tables to look like, which we've defined up here. And then we do that for every test. Notice here, same kind of pattern. It's a nested with get the container first, and then create your an instance of the DB Funcs class, which is in this case the Postgres class, and then run whatever method you want to test. The nice thing about this is that it's written in such a way that you can control the state of your database. So if you want to take, for example, it's a good example here. Down here. Oh, so here's one test. Test query should return data. And in this case, we have this ability to see the database with whatever data you want. And that could be the query that you write. And so in this case, it would be this query right here. And so if you want to change what the state of your database is, you can just do it here in line. So the nice things about this is each test is self-contained. You have all the knobs and levers you can turn if you want to adjust your tests however you see fit. In addition to that, you can also take advantage of the parameterize feature of PyTest, which you can test different inputs and outputs. So in this case, given these two inputs, this is what I expect from my tests. And then if you want to add more, just add another tuple of inputs and outputs. When I run the test, I want to run it locally. So I did ahead of time since it takes a while. It takes about, because I have a bunch of tests here and it's all creating containers. But if you run it on your IDE, this is what you should expect. You get a test, and then it runs on Postgres 10, and then you can get you can see all the results here in your IDE to see, you know, what the output was. But it's nice because you can all run it within your IDE, and if you want, you could run Postgres 8, and then that'll populate the results for each image. So that's running it locally. If I do it on the so next step is we want to test it using our script. So if we do this script right here called the run test docker, this allows us then to run this script or run our tests now on whatever Docker container we're using to deploy to in this case, to Travis. And I did it ahead of time since it takes a while. But when I run the script, what I'm doing is I'm calling it on the command line, just run test Docker. And I've configured the test where it only focuses on the one test I want to target. And you'll see in my output here that that we're running only one module, and that's the Postgres test, and it passed. So we know that it runs now locally on our machine. If we deploy this out to Travis, I'm going to switch gears now to an example. Here, I'm going to switch to the Travis CI dashboard. Share screen. Let's see here. Where is pipeline? PowerPoint. Google Chrome. I got so many here. Hold on. Oh yeah, that's the one. Okay. So do people see my Chrome screen? No. Let me do it one more time.
No, we did. We had it.
Yeah,
okay.
we saw it. It just took a second to get to
Unmuted.
the mute button.
Oh, okay.
Yeah, we saw it, but now we don't.
Oh, all right, my bad. Let me do it one more time. Virtual meetings are hard to do. All right, so if we deploy this out to Travis, I did this ahead of time because it'll take a while to cook. You'll see that that you can make
Now
it
all we have is a black screen, just to let you know.
Okay, maybe it takes a while. Sharing is paused. Bring your shared window to the front. Okay.
Yeah, it says you've started screen sharing, but it doesn't actually show anything.
Oh, that's weird. Bring your shared window to the front. Okay.
Probably just restart the share again.
Yeah.
Yeah. Weird. One more time. Okay.
There you go.
I see the green. Yeah. Also, this is ahead of time. If you deploy this out to Travis, you can see that it runs that same script that we saw on my IDE versus here. And for these purposes, I just ran the one test that I want to make sure that runs. So in this case, it's the Postgres SQL test. I'm going to switch to the actual logs here. And then if I go all the way down, it's the same screen. I'm just switching to a different tab. You'll see the same output that you saw on my IDE, which was at the test pass, and we're done. I'm going to switch back to my screen now, back to the PowerPoint slide deck. So the couple of things to get it run on Travis CI is that you need the ability to test the container. In order to test a container, you have to create a container within the container. So it requires some changes to the Docker file. You also update the requirements tests, and then update the script. So the call to run the create the actual container within the container. So that was like the hard part that I found difficult, just because it does work on my machine, but then when you want to create the container. Within the container, that there's some adjusting that had to be done on Dockerfile. Some key takeaways. Again, just make sure you sleep your container before making that connection. If you can avoid creating Dockers from a container with a container, try to, because it does take somewhat effort. At least for me, it was a steep learning curve to get it to work. Another thing I learned is that when you do create a container from a container, they're not children actually, they're siblings of each other. So they're all in that same level. And the nice thing about that is that the host then has visibility on all of the containers that are created. And if you want to make sure that it works correctly on Travis, just create your own Travis account, throw a branch, which then confirms that stuff is working as expected. One thing I did notice earlier when I was going over and refactoring the code was that in order to run a Docker command within a container, you have to have root privileges. I mean, everyone knows that, but the thing is that our Docker, or our user that runs these PyTests is not root, but it's actually a Volttron user. And an issue there is that you have to add that to the Docker group in order to have those privileges to run Docker commands. And that's like a gotcha that you have to be careful of when you're kind of doing this test framework of using Docker as a testing tool. So yeah, that's all I have.
All right, thanks.
Mhm.
So yeah, this has been a good effort to give the Volttron test suite some new attention and take it in new directions to try and improve, the speed. There's a lot of tests, and in several cases, we're testing things with ZMQ and then running the same test with RabbitMQ. So that just doubled the time for a lot of things. And so this was an attempt to try and fix that and get some more stability on Travis.
So there's one of the things that I just wanted to bring up with this with the test suite here. Some of the cool things that we're doing with it is actually we've wrapped the Docker API into some different. It's almost like a Docker Compose, but not a Docker Compose, because we needed some of the low level stuff that Docker provides. So that's some of the cool things that were shown in this picture, but weren't necessarily brought up. So
Okay. Any questions?
So did this improve the speed?
Yes. Go ahead, Craig. Sorry.
no, you go ahead.
Well, at least it improved. I wouldn't say I can't talk to speed, but I would say it does give me. I can actually get feedback when I run a test versus running and one of the integration tests that we currently have, because sometimes it takes a while just to spin up, and then it fails or it runs, so it's kind of indeterminate. But with this, I can actually get feedback quickly on whether my methods are working correctly or not. So I'd say I get an improvement on actual feedback in a timely manner.
I think also that some of the things that we're testing didn't necessarily have the integration testings on them. The historians most definitely do. So we haven't actually taken the integration tests out as of yet for those things, and so that's one of the things that we have. The unit tests, the the quote unquote level 1 integration tests do definitely spin up much quicker than the Volttron platform and running the unit tests specifically for that. Yeah, much quicker. I don't have hard numbers though.
This is a pattern worth expanding to other parts of the platform.
And I think especially as Mark mentioned, the different versions of Postgres, of MySQL, of that will pay huge benefits to the level of confidence that we have around the different databases specifically. There's obviously others, but that specifically is one of the key benefits of this pattern.
So to add to piggyback on what Craig said, when I started out, I wrote tests for the MySQL funcs class. And when I first started, I picked the version 8 image. And I was wondering why it wasn't working. And then after talking to Craig, it was most likely told me to try 5.7, and then it worked. And then I tried 5.6, and then that worked. So it kind of, one of the benefits it reveals whether your versions, if our current implementation of the MySQL funcs class is up to date, which currently it's not, at least with MySQL 8. So that's not a nice thing. Is we get immediate feedback of whether you have to make some changes to keep up with different versions of whatever database you're using.
Okay, any other questions or comments on this? All right, if not, thanks a lot, Mark. Mark is fairly new to the lab and to the project, but has brought in some great expertise and experience with testing and DevOps sorts of things. So it's been great. Thanks. Okay, that was the only presentation planned for today. So now I'd like to open it up for any questions or anything anyone else wants to present.
I had a question about AWS IoT that I put up on the Slack channel. Just if anyone knows why the version 2 SDK, the new AWS IoT SDK, doesn't seem to be compatible, whereas the version 1 SDK seems to work with the Amazon Echo Volttron example. I don't know if anyone's tried to use the new SDK for AWS and integrate that with Volttron.
No, I don't think anybody else is doing that.
Cool, that's fine. Just keep using the code that works. Just wondered. I can't figure out why it breaks, essentially. It's quite tricky because it's kind of waiting on some kind of feedback signal, but obviously the Volttron signal has its whole VIP running, and the two seem to kind of conflict, whereas in version 1 they don't. So I mean, it's beyond my expertise. I'll just use version 1.
Is it async IO versus G event incompatibility?
Okay, that's a yeah. I'll write that down.
That's generally what I find is always a challenge when you try to use modern libraries with async IO support.
Okay.
Getting them to work well with G event can be tricky.
Or could it be a conflict in those kind of base level G event drivers or something?
Well, what happens is you think you're calling a function, but you're getting or you think you're maybe setting off a listener in an async IO context, but it's actually going into a G event greenlet, and then you never find it again, basically.
Yeah, it just seems to do nothing. It seems to completely block the subscribe action to AWS IoT in SDK version 2. It does nothing. Like it doesn't, there's no output. So maybe it is a change in that. Okay, I'll take a look. Thanks.
Thanks.
Did you want, Jeremy, last meeting, I think you mentioned talking some more about some of the Modbus stuff. Did you want to do that today or another meeting? I'm sorry, I should have maybe looked up, remember what you said exactly.
Yeah, maybe we'll say that for another meeting. Let's talk about that. Was this the Modbus TK?
Yeah, you just said to maybe talk about it on one of the calls, and so.
Oh, something that you've been working on?
Well, just the entire kind of discussion around some of the, I guess what I would there's several issues I think I would classify as accessibility of the platform. But yeah.
Let's see. Yeah, if you want to, we could cover that today if you want.
I think David Raker is one of the other big Modbus users, and he's here today. So I know he and I have had some conversations as well. And I think also related to this, kind of coincidence that Mark is presenting on testing the Postgres historian, or specifically the underlying module for connecting to Postgres. But I also had an issue I opened a long time ago for discussion around improving the Postgres schema. So I don't know if anybody here has been thinking about that in parallel. I've certainly done a lot more since I posted that issue on ours. Learned a lot more about what works really well inside. We're using Timescale DB.
So funny you should mention that, because I just came up with a couple things dealing with Timescale, and we're moving towards Timescale here at the lab. So now would be a good time to talk about that. I don't know if we need to record all of this, but it would. I think that would be a perfect time to take a look at what you want to, whether you want to produce a pull request or whatever, to take a look at.
Well, I think
thoughts.
My goal was to have it not be, I have one kind of use case, and I was hoping that maybe if we all sort of contributed to a discussion about it, we could come up with the sorts of, more robust discussion that would lead to maybe a more general purpose schema. Again, kind of going back to like a lot of the things in the Volttron ecosystem are contributed based on the use case of one user who had resources to implement something. And then that is not necessarily kind of scaled back up to what is the most general application. So I wanted to be careful not to just implement what I wanted and push it, and then everyone would be stuck with the way I see the world, versus maybe if there was a more general solution that.
Do you have something that you can share to start to kick us off?
I have not changed mine yet, but I can talk about what I've learned and the things that I think will support a better performance in at least my use case, if that makes sense.
Go for it.
Okay.
Let's see what we got.
So I was trying to see if I could generate a quick visual of our table structure here. Don't see a way to do that. I should have done that prior.
Yeah, well,
But-
you didn't know that we were going to be so amenable to talking about it today, did you?
Well, I was going to bring it up anyway, but you know,
Like I said,
when does
Well, then it's
amenability
then
stop
being
me?
prepared. I tried to give you an out there, man, but you know.
So hopefully everyone's familiar with the existing structure that's created by default for the Postgres data table, and I think it's kind of
It's kind of a
maybe
mirror of the MySQL. 'Cause
yeah,
MySQL
exactly.
came first.
So
Yeah,
so
basically,
there's a data table, which is your kind of raw time series data, and when we are talking about time scale, that's the table we would apply the
Hypertable.
time scale optimization for with the hyper table and split it into chunks. There's a topics table and there's a meta table. To be honest, I have never used the meta table.
Yeah, we're going to combine those two. I think there's no reason not to combine those two, right?
Right. So I have in my system, because I needed to implement a layer of multi-tenancy on top of this, I have, a lot of other tables like what I think you had as point or as meta and topic ID or topics. I kind of combined into this table I call point, which may or may not be a good naming scheme, but it is essentially the topics table with the metadata there as well. And I've added, instead of I have some specific metadata rather than just a freeform JSON blob or HStore. So I have additional columns there on top of what you have even in the meta. Then of course I also have things like metadata about other entities in the system, so not data related to the point itself, but data like there's a table for the sites that the Volttron instances are deployed into. There's a table for the clients that those sites are associated with. So all that rolls up into views for each client such that those views are limited to only seeing the data that's related to their sites. I think the main thing that would support better performance is that merging of the topic name and the meta table.
Yeah.
Right now we do a lot of dumb joins where we're just looking up the topic name for that topic ID to then correlate to other things. And this gets, I think, more important when you're doing things that aren't necessarily generated from Volttron. So like we're starting to integrate data flows in from MQTT that come into Volttron but aren't Volttron native data points. And so for those we are using the topic name as provided by the MQTT broker in a lot more kind of primary key way than Volttron generating the ID for the point. So anyway, I think that was the main thing. The issue I opened a long time ago was really around the indexing. So I think by default there's just an index, B-tree index on the timestamp in the data table, and it is in descending order, which is a little weird because rarely are you loading data from the beginning of time until the end of time. You're normally looking at the, your frequency of data access goes down as the, time into the past extends. So one of the things I've done for mine is adding a descending order index on the timestamp field.
Okay, so you said descending twice there. You meant ascending, and then you added descending. Yeah.
Yeah.
Okay, that's what I thought you meant, but I wanted to verify that. Yeah, that was one of the things that I was looking at as well.
And that's been very helpful. I've started to really dig into some of the other indexing recently. I have a query that's, it was taking like 30 seconds to run for a month's worth of data, which is a long query for that short amount of data. But it was a lot of the use cases we have end up doing self joins on the tables. So I don't know if other folks are doing those sorts of workflows, but
Do you know if adding a view on top of the join tables will improve performance of that specific view or not? Like, does it cache? Does it perform a cache in the back?
No, the query
that does
planner.
that?
No, the
Or is
query
it just
planner.
a
The query planner destroys views before doing the query.
Okay.
In every case where I've done an analysis using the view data. Now, sometimes it's counterintuitive how it deconstructs the view, and maybe you could assemble a more optimal query if you did it manually, but in general, it's breaking it down to it's not treating the views as a CTE, for instance. The views get, the
What's
pieces
CTE?
of the. I knew you were going to ask me that, Craig. I honestly don't know what
when you throw around acronyms that are
I know.
certainly not in this context going to.
I was hoping someone else would know exactly what a CTE is. I could tell you what it is. I can't tell you what the acronym stands for.
All right, that's fine. What is it?
So a CTE is if you, in general, subqueries in Postgres also get deconstructed by the query planner. So if you do a select, X, Y from subquery, X and subquery Y, then when the query planner looks at that query, it deconstructs all of that and rearranges all your limits to what it thinks is the most optimal way to run that.
Got it. Okay.
A CTE is when you run a with at the beginning of the query that says with X as subselect. CTEs will run, and it's not that they absolutely won't be deconstructed, but the perceived cost by the query planner is seen much higher, so it will try to solve that as a entire set of processes and then take the resulting intermediate table and perform the rest of the query with that resulting intermediate table. So if you want that behavior, you can use CTEs to accomplish it, but views by default do not behave that way. And I've been really diving deep into Postgres the last 7 days. I'm sorry if I'm just
No, dude, that's good. This is actually very timely, as
acronym.
We're doing stuff on what?
Oh, sorry, I didn't mean to interrupt you.
Do you have the definition of the acronym? I didn't Google it. Sorry.
It's common table expression.
There you go.
Huh. Okay.
So, I don't know how common table expressions are. I'm not, super DBA or anything. But I had been playing with them a little bit, where I had a query that was exhibiting very what I thought was odd behavior.
So the reason that I asked about the views was to make the retrieval of data just even more easier, rather than writing the join for each of them. You just have the view, because MySQL supports view and that, so that we can roll those up and just use the views rather than have.
I don't have any secrets here, so I can show you what that looks like in our system. This is for one of our clients, and this is what that view looks like. So it's exactly what you're talking about. So
yeah, that's what I'm thinking. Yeah.
What I want to do by merging point, in my case, or meta and topic, I can eliminate an entire join, which these are generally cheap joins anyway, but it just feels better. And I think it gives the query planner more latitude to find optimal solutions. Like the fewer degrees of freedom it has, the better off you are, because it is,
sure,
it's sort of Bayesian in its approach, and so it is subject to finding local minima that trick it into providing you suboptimal queries.
And the only reason that metadata table was actually originally proposed was to handle if the data for a specific point had changed. But in reality, I don't think that has ever happened.
Well, so what I do for that is I just add a field, because I mean, when we're like, when you start talking, even if we're, I've got maybe 100 and I think, close to 200 million records in the time series portion of this database. But there's 50 or 60,000 topics, and not all of those are fully I should say there's 50 or 60,000 points, because I generate points when I scan a site versus when I start trending data.
Yeah.
And so the actual topics may be even less. It may be 6 or 7,000. I don't know. So I think it's pretty safe. Just we can make that table as wide as it needs to be. There's no real danger in having performance issues on that table, because
On the topic table. Yeah.
Yeah. And I can show you. I mean, this is what my point table looks like. So points have their own ID, which is not the same as a topic ID, which was probably a mistake on my part when I set this up. But anyway, we're mapping the topic IDs in, so we don't have to do that join. And then, I have a site ID, a client ID, and then I have an updated and created column. And
yeah, so this part wouldn't be in regular Volttron, I would assume. Is that correct? Or
well, I don't know. Like, I think if you're trying to solve I think you should provide so this gets back to like how tagging works in Volttron, and whether tagging is a real solution in Volttron or just kind of a weird bolt-on thing. But I think
it is kind of a weird bolt-on thing right now.
Yeah,
But
so I think you need to be able to support arbitrary metadata for the user. And so I'm doing that with a couple of H stores on this point, which is the equivalent of meta or topic in the vanilla. But you could just have a user data column that was an H store. JSON, binary JSON is probably a better choice at this point. When I did this, I was based on some older knowledge and releases of Postgres, but the JSON B type is really powerful.
But how would you get the data into that? I guess is one question, because the way that currently Volttron does it does it through the message bus, right? And when something shows up on devices or one of the different topics, it just dumps it in there, and it creates the topic at that point in time. How would you see changing that pattern to allow you to add these user-defined things in that topics table, and to make it be queryable too?
How does tagging work?
So tagging,
I know it's got its own agent.
It's got its own agent, and it adds different tables on top of these tables that are aggregation tables. And then it does the mapping and allows you to query based upon tags that way.
Through Volttron.
Through Volttron, yeah.
Yeah. So I would imagine a world where if you wanted to, you could tell your tagging agent, if it needs to be an agent, to store the data in the native data store where you could query it from other applications. And that would be a much more powerful.
Well, I mean, that's what it does, right? It stores it in the native database.
In a completely separate data store.
No, it's the same database.
In different tables. I'm sorry.
Different tables, yeah.
Yeah, so you're back to this.
It has a couple new tables, yeah.
Yeah, you're back to this joining, compound joins to achieve where your metadata is never going to be that large of a data set.
I guess if we wanted to think about that paradigm, what we could potentially do is add columns from our base historian that are just sit there until the aggregates are used, and then use those for the hooks if something
Well,
goes wrong.
like, so aggregate, I think of aggregates as a separate problem.
Yeah,
And I
I
don't
said
know that, like,
aggregates, but because that's what we call.
and
that,
you don't really
yeah,
need,
you're right.
I mean, you don't need,
Aggregates is not the correct term, but
well, you don't need aggregates in a
Yeah,
SQL
yeah.
engine, because you could just, you could just have, if you want aggregates, you could just set that up as a trigger that gets instantiated when you initialize your historian. So instead of, like, right now, your way your aggregates work, because you did it to support Mongo, is you
Right.
read data, you do the aggregation, and you write it back into an aggregate table, right?
Yep.
So in this case,
you definitely could use trigger on SQL to do the same thing.
yeah, and then you wouldn't need to do that. Like, you wouldn't need all that two-way data traffic, and it would be a lot more performant, and it would be kind of native to the database.
So I don't know how many people are actually into this conversation. I am. However, I think we ought to would it be okay if we set up something later, like next week, and we'll send it out to the group at large, and we can talk through this some more? Are you
Sure.
good with that?
Yeah, absolutely.
Yeah,
And more importantly, you okay with that, Jeremy?
Yeah, well, I was thinking Wendy might ping Wendy, see if she's interested.
Wendy would be another person that would be good at this. Yeah.
Yeah, I think I know. I think I've spent another like 40 hours on this since you and I and Wendy talked last. So
okay, cool.
That's
much more insight is what you're telling me. That's good.
Well, I don't know about that, but
no, I'd say that.
Andrew, are you okay with your screen having been recorded?
Yeah, it's fine. There's nothing. I mean,
just making sure.
Yep.
Okay. Well, cool. So yeah, let's. So Craig, you're going to schedule that.
Yeah, I'll schedule that, and do you want to be and then I'll send it to you, and you can send it out.
Okay.
Well, I will go ahead, and while everybody, or the like 3 people who didn't hang up because of how bored they were,
kind of deep it got, yeah.
I will say, like, if folks are using Modbus, either Modbus TK or Modbus, and you have thoughts about it, please comment on the issue I opened, and like, let's figure out how to simplify that space. And I don't know that I've issued a PR yet on Modbus TK functions, but I've developed, I don't know, several recently to support some of our use cases.
Be kind enough to create a PR for that so that we can pull it in.
Yeah, it was one of those things where, like, I hammered out some stuff. I think I sent David some broken code, and then I finally got a chance to test it and finished getting it worked out, and then I haven't committed that stuff yet. So
yeah, I got a little behind and haven't actually had a chance to test that myself yet. Sorry.
Well, I haven't tested the specific thing you were looking for, the padding, but it's a very good chance it is still broken. And I think I brought up in that issue a different approach to the padding, in that when the client in Modbus TK is planning or kind of walking through the registers to make requests, there's an opportunity there to just sort of set a tolerance for the amount of gap that can be that would be ignored. Right now, if there's any gap at all between registers, it starts a new request. It would need to be optional, I think, because there are devices where the Modbus access is not as sort of stateless as you would expect. There could be registers that you wouldn't want to try to read from, because that might mean there might be some side effect. So you would need to make it optional, but it might be a simpler way we could just default that tolerance to 0, and then you could say, for these devices, I want to set that tolerance to a gap of up to 10 registers. Go ahead and read as contiguous area.
That could work. I mean, what I had been playing with was just to have a register type that was a pad that said,
it's just an explicit,
throw away this many registers as you read.
Yep.
Yeah. Because then it just queries the whole range. I don't think
both
I
are possible.
anything that would have a side effect, but I don't know in someone else's use case if there might be.
Yeah, there are some weird devices out there that do things like monitor when the register's read from and then take some action based on that. It's not a, yeah. Exactly. So anyway, there's that would be the reason not to do it the way I just said, but it could be a setting, and it would make your register files cleaner if you didn't have to add a bunch of pad registers or whatever.
So one of the things we have difficulty is when you raise this pull request, we don't have hardware here to actually test it and confirm. So when you do the pull request, can you please test it thoroughly with all the hardware that you have so that we can pull it in with confidence?
That's been my issue as well. I think the ones that the devices that I've added a bunch of functions for in the translate or transform.
That was the helper functions, right?
The transform functions
or whatever.
Yeah, it's the crap. You threw me off. It's something 850. Is it M? It's not T. Something 850. Anyway, the Schneider square D power meters. Something 850. PM 850. That's what it is. PM 850. So those, I don't know. I'm kind of surprised y'all don't have some of those available in a lab somewhere.
I don't think we have any of those at UT, but we have a few CM 1000 and 2000 type.
Yeah, the difference in the 850 that I found from whatever was originally developed, because Modbus TK actually has some device profiles for a lot of the Schneider, but the difference is that the ones in Modbus TK only go up to 32-bit Mod 10 registers, and the PM850s have up to 64-bit ones. So that was kind of a pain in the butt.
The ones we have definitely have the 64-bit for the energy registers.
Are you reading those already without the Mod 10? Like, how are you reading the
We're just reading power.
Oh, okay. Well,
we're reading power frequently. So.
The Mod 10K64 definitely works. I've got that. That's been tested and run and works well. The ones that I've only tested now with one device are it's called bit flag. So again, because Modbus is such a loose standard, some companies support binary data packed into the holding registers as bits in a word. So the bit flag will allow you, and it's very inefficient right now, and it's something I'd like to address. But right now, the bit flag function will read that word and then extract a positional bit in that word as a Boolean. And that's tested against some elevator equipment that I have access to, but I haven't tested it against a broad array of devices. But I think, David, you were interested in that functionality as well, right?
Yeah, the BES makes a lot of use of that sort of thing. I didn't do anything with the driver for it. I've just, but I have similar functionality at the level of the BES agent that pulls apart the integer and
you're probably better off
bits out of it.
better off doing that for now because it's so inefficient, because essentially what Modbus TK does is it generates a new request for every one of the bits in the register. So I'll dig into that and try to optimize it, but it is, if you're not doing that frequent of reads, it's fine.
There's no way to
Okay.
do like a post process on it after it comes in.
It is a post process, but basically there's no deduplication in the Modbus TK, so it's pretty simple to add deduplication, and I think that's the tack I'll take, which is if you see registers all with the same address, read it once and send the data to all the things that were requesting that.
Because it would be useful for monitoring certain things, possibly to actually have them in separate fields.
Makes it a lot easier to visualize in real time if you've got that kind of stuff.
Most of that for the best is just like error codes. So if there's any non-zero value, it's an error, and then you worry about it. But I could see other cases where that might not be true.
What are I guess that brings up a good question, Swetha, is how they're doing all this testing. Is there not a device lab to test against?
We have the campus, which is
we have the
all
campus
BACnet
and the
based,
devices.
But not like a isolated environment where we could actually build some of this stuff out into unit tests.
So I believe that we're kind of
not currently.
Yeah. So I think Jeremy Penny was making an IoT lab, which would have a sort of similar theme to that, but I mean that would be with things like Google Homes.
So we do have dedicated lab setup in PNNL, but for the building side of things, it's limited. For the grid side of things, it's more elaborate. So we'll have to check on that test bed if there are some Schneider devices that we can test, and then we'll need permission to test and things like that. But we don't have a dedicated Volttron lab here with all kinds of devices. No. We directly test on the campus and the devices that are in the buildings.
Would it be useful to have like a Modbus server that could be configured to simulate different devices?
So I think the short answer is yes, but I believe that last year at the meeting, Brendan Carpenter did a presentation on what was it, Modbussy or something like that.
Modbusy.
Modbusy, whatever. I think we should probably dust that off, unless you have a different take on what you're thinking about, David.
I don't. That's just the only thing I can think of to come up with, because you're never going to have all the devices that somebody out there would have, but you could potentially get the map for the device and generate a configuration for the thing.
It certainly would enable, like, if we had some way of simulating that, it would certainly help, I think, on the development side.
Well, maybe we should, like I said, dust off Modbusy and take a look at it and see if we want to cover that at a future office hours with an example.
Sure. I think that sounds like a good idea. I think that's, does one of the community want to take part in that?
can't say that I have a lot of time to commit to
Well, that's
it.
what I was thinking.
I know, right?
I have no idea how difficult it would be to make sure that you're actually simulating the thing correctly if you don't.
Well,
Yeah,
I mean,
that's
what-
we don't
beyond
yeah,
beyond the
that's
points
true,
and
too.
their names, you're not going to. I mean, if there's anything that's in the hardware or anything specific to that device, you're not going to get it.
Yeah.
So you can test that you're able to get points that have the same names, but beyond that,
Well, I think one of the things that might be interesting, like was really hard with the mod 10K stuff, figuring it out is like if you had implementations that were tested against the device, and then you could just generate like monotonic counters, so that like you always know if you're not getting an increment in your value, you've got your data, interpretation, like those kinds of things, and have some unit test around that, the data conversion stuff when you get into some of the weirder data formats. I think it could be helpful because I spent a lot of time figuring out what the exact byte word order was for those 64-bit mod 10K registers.
So you'd be willing to be a guide?
I think I have, like, maybe this is just a discussion of like a need and like the fact that this is kind of tough for our community, and then we have to, push it off until we have, like, certainly the database schema stuff is much higher priority for me. That, I can put
Oh, for
energy
me
into
too.
it.
I agree with that as well.
So-
yeah. But okay.
all right.
Well, we can certainly put it on our list of
Back burner.
back burner future things.
I do think another thing, and maybe I'll post an issue with it, but when we talked about the data stuff last time with Wendy, and I kind of laid out the not quite streaming data lake architecture.
Mhm.
I think I may turn that into an agent that can run in Volttron, and like probably in the short term just use the historian framework and use the SQLite database as a cache, and then flush every n minutes to an object store.
To long-term data.
Yeah, so I don't know if folks are interested in that, or would have any input as to what kinds of features they might be interested in that I'm not thinking of. But by default, I would just do sort of a replication of what we're doing through external means inside of a Volttron agent.
Sounds cool.
Anyway, all right.
Okay. All right. Well, we will talk to you later at the database meeting then.
Sounds good.
All right. Thanks a lot,
Later,
everybody.
guys.
Thanks for
Bye.
presenting, Mark.
Yeah, thanks. No problem. Bye.